Hello and welcome all. We shall see now fixed tube sheet 1-2 heat exchanger. So in fixed tube 1-2 heat exchanger, tubes are fixed into sheet. Okay, the tubes are fixed into sheet. Apart from this, the tube sheet is also welded to a shell. Okay, which is also welded to a shell. Tubes are fixed into the sheet. Tube sheets are welded, and moreover the shell have extended portion. Okay, the shells have extended portion or that of the shell, or I must say the tube sheet have extended portion than that of a shell. So this extended portion of tube sheet would act as a flange support. Okay, would act as a flange support in order to connect or attach the channel. Okay, channel cover and channel. Okay, so this is here you can see the tube sheet is little extended over that of the shell, and here it is acting as a flange support and attach the channel. Okay, attach the channel. Moreover, this channel that is provided is having a channel cover. Okay, this channel is having a channel cover. So there is a different arrangement, and as we know that the classification that we have done is based on a schematic arrangement in the heat exchangers, and moreover material of construction. So material of construction and arrangement that is in the heat exchanger is a basis for the classification of the various types of heat exchangers. So here in this case, what is given, this channel. Okay, this channel here, this channel is also having a flange support over here. Okay, you can see it over here, the flange support, and therefore this can be separated, okay, from the channel, or the channel core can be separated from the channel. As well as we can see that this channel is having the pass partition, and here it is only one pass partition is there, and therefore we can say that the fluid that is entering into the channel and which passes through the tube side make two go, or I can say that we can say that the fluid passes or make two passes from the tube side, or can make the two passes from the tube side. So it is because the pass partition, one of the pass partition is provided in the channel. Okay, so overall we can say that the tube sheet, okay, tube sheet is fixed with the shell, as well as it is little extended so that it can act as a flange support to hold the channel. Moreover, the channel on the other side, okay, on the other side is having a channel cover, which is also flange and can be removed as required. Okay, it can be separated as required. This channel is having pass partition, since there is only one pass partition, and therefore the tube side fluid can pass twice through the tube. Okay, or the fluid that is entering through the channel into the tube side, it passes, or it make two passes, I must say. It make a two passes like this one. The fluid enters, and here it can go out. So this is possible when the other side of the heat exchanger, okay, other side of the heat exchanger is closed. That means the channel is closed on either side. Okay, the channel is closed on either side, or is having a flange support on either side, but there is no entry or exit, inlet or outlet onto this other side of this channel. Okay, and therefore the fluid that is entering from one side of the channel enters through the tube, and it finds no way to go out, and therefore it returns back into the tubes, and therefore we can say that the fluid that is entering make two go, or it passes twice through the tubes. Okay, passes twice through the tubes and exit from the other side of the channel, because one of the channel is provided with inlet as well as outlet, inlet as well as outlet. So the fluid make to go or make two passes, one from this side and other from this side. Okay, and that is why the name is given 1-2 heat exchanger. One means that is the fluid that is passing from the shell side would go once, while the fluid that is passing from the tube side would go twice. Okay, would go twice. That is the name 1-2 heat exchanger. Next part is on the other side of the shell. Okay, here the other side of the shell. Okay, or in the heat exchanger, one side is having a channel which is having inlet and outlet as well as the pass partition, but the other side of the heat exchanger is clamped. Okay, it is clamped. This is clamped or this is clamped. So it means that the other side of the heat exchanger is completely although the channel is provided, but it is closed. Okay, it is closed with nuts and bolt, so that the fluid may not cross the boundary. Instead, that it would enter again back into the tubes. Okay, similarly this shell, okay, when we talk about this shell is having two openings, one for the inlet of fluid, okay, one for the inlet of fluid and other for the outlet of fluid, so this is the arrangement. Okay, in this arrangement there is a possibility, however, that mechanical cleaning was the drawback of this fixed tube heat exchanger. Okay, so inside cleaning of these tubes is required, as the scale formation may take place. Okay, scale formation may take place inside the tube, as continuously one of the fluid runs through the tubes. So periodically the mechanical cleaning from inside is required. So this is not possible to do the mechanical cleaning from inside. Okay, mechanical cleaning from outside, I must say. Okay, mechanical cleaning from outside is not possible. Okay, as this is fixed. Okay, this is fixed. Okay, this is fixed. This tube sheet is fixed, as well as tube bundles are fixed in the tube sheet. So mechanical cleaning from outside is not possible. Okay, outside is not possible, I must say. Okay, mechanical cleaning from outside is not possible. However, the mechanical from inside is possible. Okay, you can just take this channel cover out and cleaning can be done from inside of this tube by some brush or anything else you can use to clean the tubes from inside. But outside cleaning of this tube is not possible, because this is not accessible, or this cannot be separated, or this tube bundles cannot be dismantled from the shell or through the shell, so that cleaning could be done. Okay, so this is what a drawback of this fixed tube heat exchanger, as most of the fixed tube heat exchanger are fixed or the tube bundles are fixed in the sheets, tube sheets, as well as the tube sheet is fixed to the shell. So inside cleaning, outside cleaning is not possible, but inside cleaning of this tube bundle is possible. On the other hand, as we want to achieve the multipass, okay, multipass. So multipass construction, why we require the multipass construction? Multipass construction we require because what happens when the fluid passes, it need to be passed with high velocity. Okay, it has to make one go, more than one go. Okay, the fluid has to pass more than one fluid has to make more than one passes, and that is why the the fluid should pass with high velocity, and this is done by means of some pumping. Okay, pumping is required to give this fluid which is passing with to move with a high velocity. Otherwise the fluid, if they are moving with low velocity, okay, the decreased velocity, then what happened, the heat exchange would not take place. Okay, heat exchange would not take place, and that is why the pumping cost add to this construction, multipass construction. Pumping cost add to this multipass construction, because we want the fluid to pass through the tube side more than once, okay, more than once. It depends upon how many pass partitions are there. Here in this case it is 2, that is why the fluid would pass twice through the tubes. Okay, so this is what a multi-pass construction require high fluid velocity, and so pumping cost is required. As the fluid, when it passes, if there is no pumping arrangement, then in that case there would be a high friction while the fluid is passing through these tubes, and that is why, to avoid this friction or to lessen this friction, what we require is the pumping. So multi-pass construction require pumping. Okay, pumping. So here, for economic design, okay, for most of the fixed tube sheet 1-2 heat exchanger, when they are designed, it is taken into consideration the balance between fluid velocity and pumping cost. Okay, fluid velocity and pumping cost. So this is what, for economic design, what we require. The balance should be there in between the fluid velocity and pumping cost. Okay, so economically this should be best suited and become chief, I must say. If pumping cost added to this, as in the form of cost, then what we can say that the cost of this fixed tube 1-2 heat exchanger would increase. So we have to, for economic design, there should be a balance in between fluid velocity and pumping cost. Now, so far what we have discussed, fixed tube heat exchanger. This fixed tube heat exchanger have certain disadvantages. So when you talk about 1-2 or 1-2 shell tube heat exchanger, in 1-1 shell and tube heat exchanger, which is operated in a counter current flow, it is very difficult to obtain the high velocity from the tube side. As if it is a 1-1 shell and tube heat exchanger, so high velocity is not possible to be maintained when the fluid is flowing through the tube side, because it is not connected with any pumps. Okay, it is not connected with any pumps. But as the multi-pass construction, as we go, or as we keep increasing the many number of passes from the tube side, then pumping is required, as there will be a friction while the fluid is flowing through the tubes, and that's why pumping is required. And that problem that we can maintain, that problem with regards to the velocity of fluid that is passing through the tube, can be resolved if there is pump or pumping arrangement is associated with the fixed tube heat exchanger. This is a disadvantage, because 1-1 shell and tube heat exchanger do not carry or possess any kind of pumping, so high velocity cannot be given to the fluid passing through the tube side. What is the advantage of this shell and tube exchanger? As already been told, and we've been discussing, that this fixed tube sheet exchanger is cheapest because of the ease of fabrication. So it is very easy to construct, and that's why it is a cheapest type of shell and tube heat exchanger. Now, what is the main disadvantage of fixed tube sheet heat exchanger? Okay, this is the main disadvantage of fixed tube heat exchanger. This heat exchanger continuously require periodic cleaning. Okay, periodic cleaning, sometimes replacement of tubes. Okay, sometimes replacement of tubes also. Since, as we discussed, that inside of the tubes, okay, inside of the tubes, fixed tube or tubes can be done. Inside of the tubes can be cleaned by mechanical means. So by using brush or worms, the inside of the tubes can be cleaned. However, it is not possible to clean the outside of these tube bundles. Okay, since these tube bundles are fixed in tube sheet, and apart from this, the tube sheet is again fixed to the shell, and therefore whenever we want to perform mechanical cleaning from the outside of this tube bundle, or tubes, when they are to be cleaned from the outside, it is not possible to dismantle the whole of the tube bundles from this shell, since they are fixed to the shell. Okay, they are fixed to the shell, and that is why this is one of the most important disadvantage that fixed tube sheet heat exchanger may have. And this would make this shell and tube heat exchanger rather cheapest. Okay, but for one installation or many installation, what we require this disadvantage for more for installation in which if you want this shell and tube heat exchanger could last long, what we require a continuous maintenance that we have to perform regular maintenance is required. So dismantling of each of the accessories that forms the shell and tube heat exchanger should be in consideration. Otherwise, what happens if all are fixed, then mechanical cleaning can be a disadvantage. So all these accessories can easily be dismantled, and whenever we require any kind of cleaning, that this can be done. If each of the accessories making the shell and tube heat exchanger is not fixed, it is separable. When it is separable, so mechanical cleaning of any of the accessories like tube sheets or tube bundles can be done. But in in fixed tube sheet exchanger, one tube shell and tube heat exchanger, it is not possible, as the tube bundles fixed in tube sheet, and in turn tube sheet is fixed to shell, and therefore it is not possible to get it separated from the body of this shell, body of this heat and shell and heat exchanger. Moreover, as we know that with the fixed tube heat exchanger, the high stress developed between shell and tube, leading to loosening of the tube. If the material of construction to make material of construction for making the tube as well as the shell is different, then high stresses may develop. Okay, high stresses may develop because you know that the coefficient of thermal expansion, this property of each material is different. Okay, each material is different, so it is rather best suited to use what the material of construction of shell and tube as same. Otherwise, if the material of construction is different, then this problem of high stress may develop, and which could lose the tubes which is fixed in the tube sheets. Okay, the tubes which are fixed in the tube sheet could get loosened if high stresses is continuously get developed during the process. So this is again a disadvantage, but this can be resolved if we use the material of construction same to construct the shell as well as tube. Okay, because the coefficient of expansion of the same material remains same, while the coefficient of expansion of different material would be different. So high stresses could be avoided if the material of construction while designing the shell and tube should be same.